Precalculus, Unit 1, Day 6. Let's get to the notes. So in this set of notes, we're going to talk about inverses. Now, what do inverses do? Well, inverse functions or inverse operations undo each other. You know, we've talked about if you have a number, let's say we start with 5, and you square root it, and then you square it, well, that gives you what you started with, the 5, okay? Because squaring and square rooting are inverse operations, and they undo each other. They give you what you started with, right? Well, now we're going to look at different functions, and we're going to look at inverses graphically, and then we'll look at some tables right here. All right, so right here it says the graph of f of x, which is the blue graph, and its inverse, the green graph. By the way, the inverse has a notation like this. This actually means, if we were going to read it, we would read this as f inverse of x. That's how we would read that right there. F inverse of x, right? That is not to the -1 power. That is not an exponent. That is just notation, okay? So this is f of x, and then this is the inverse of f of x. It's f inverse, all right? So visually, when you graph a function or any relation and its inverse, they are reflected over the line y equals x. So you notice the orange line here, right? For every point on the original function, f of x, there is a mirror image point on the inverse graph, right? So if you have this point here on the original function, there is a mirror point, okay? It's a reflected point over the line y equals x, okay? A little bit different because you may be used to reflected over the x-axis or the y-axis. This one is actually reflected over the diagonal y equals x, okay? So visually, that's what you have. All right, now let's look at, if you go down here just a bit, same page, we're going to look at the chart. F of x is actually the graph of 2x plus 1 that we saw there. Okay? So here we have a nice little xy chart giving us some ordered pairs. Okay? Its inverse is x minus 1 all over 2. And again, you have a nice chart with some xy ordered pairs from that function. Okay? Now, is 2x plus 1 a function? Well, look at it. Does it pass the vertical line test? Absolutely, it passes the vertical line test. So yes, it is a function. Now they're asking, is it a one-to-one function? Right? Now, a one-to-one function is probably a new concept for you. So look right down here where it says what a one-to-one function is. A one-to-one function is a function in which both the x's, which would make it just a regular function, the x's don't repeat, and the y's don't repeat. So if the x's repeat, it will violate the vertical line test. So conversely, if the y's repeat, it will fail a horizontal line test. So this is asking, does it pass the horizontal line test? So if it's a function, it passes vertical. If it passes vertical and horizontal, then it is one-to-one. So let's look back here just for a second. Okay, this blue line, does it pass the horizontal line test? Yes, it definitely does. Any horizontal line will only intersect the blue graph, f of x, at most one time. Okay, so yes, it is one-to-one. Now, f inverse, which on the previous page was the green function, is this a function? Yeah, it passes the vertical line test. Okay, yes, it is. Okay, so couple of things. First off, if this is a yes, this is going to be a yes. Okay. If a function is 1-to-1, then its inverse is a function. All right. So you might want to write that down somewhere. If a function is 1-to-1, if there's a yes here, then its inverse is going to be a function. Now, let's answer these two questions here. First question, what do you notice about the points? Well, take a look at this. -2, -3. That's one of the points on the original function f of x. Look at the point that happens to be on its inverse. -3, -2. So what happened here? Well, the x used to be -2. Now the y is -2. The y used to be -3. Now the x is -3. Interesting. Okay. -1, -1, they're the same. Oh, look, that same point is there. 0, 1. Okay, so x was 0, y was 1. Well, look at this point right here. X is 1, y is 0. Okay. Very interesting here. They switched it up on us a little bit. So how would you generalize this? Well, you could just simply say, if we get the lights back on here, if we can, there we go. You can just say that the x coordinates of f of x became the y coordinates of f inverse of x. And vice versa, the y coordinates of f of x became the x coordinates of f inverse of x. Okay. So the x became y and the y became x. So they just traded their y's and their x's. Okay, and to bring back a little bit of vocabulary from earlier, they traded the domain for the range, because the domain is all x coordinates, the range is all y coordinates. Okay. So it says, what is the equation of the line of symmetry for the two graphs? Well, I already kind of gave that away. The line of symmetry is y equals x. Well, guess what? When we make an inverse, all you do is you swap the x's and the y's. So that's why it's a mirror image over y equals x, because you just took the x from the first function, put it into y. You took the y from the first function, put it into x. So the x and the y turned out to be equal to each other. Okay, y became x, x became y. Okay, let's move on to the next page. The inverse, f inverse of x, of a function, will be a function if f of x is a, and we already said it, a 1-to-1 function. 1-to-1 function. Right? So if you have a 1-to-1 function, then its inverse is going to be a function. Okay, it will pass the vertical line test. All right. Next up, to find the equation of the inverse, switch x and y, isolate y. Right there, you're going to need that. Put like stars or asterisks or whatever you need to do here. All right, let's celebrate that one. If I say find the equation of an inverse, swap x and y, isolate y. Those are your two steps. That's big. Okay, that's a big one. I'll make arm motions here. Yippee. That is a big, big point right there. You want it. You want to remember this one. Don't forget. Okay, so as I said before, because we swapped x's and y's, that means the domain and the range switch. It's kind of convenient because if I say the domain of f of x is like all real numbers, well, that means you now know the range of its inverse, because the domain for the first one is the range of the second one, and the range of the first one is the domain of the second one. All right. In order for f inverse to exist, the domain of f may need restrictions. Okay. For example, this right here, what does squared look like? What does x squared look like? X squared looks like this. So if x squared looks like that, does it pass the horizontal line test? No, it doesn't. Okay. Is it a function? Sure, it passes vertical line test. But is it a one-to-one function? No, it's not. So probably the most difficult concept in this particular section is this. If I want the inverse of something to be a function, I may not be able to use this entire f of x. I may need to restrict its domain. I may need to do this. I may need to erase a little bit of it so that, ooh, now look at that. That looks like it would pass a vertical line test and a horizontal line test. Okay, so we may only be able to use part of a domain if we want to make the inverse a function. All right, so let's continue to read here. Say we may need restrictions. So for example, f of x equals x plus 2 squared minus 1 must have its domain restricted to something in order for its inverse to be a function. Right? Now, if you graph this, right, you have, as I mentioned before, let's make a fresh one here. Okay, this vertex will be at -2, -1 if you graph this on your graphing calculator. All right, so that point right there is at -2, -1. So if we restrict your domain down so that you have a one-to-one piece of the original function that you're dealing with, we would only be able to use, again, we restrict the domain. Domain is x's. Here's your x. We would go from -2 to infinity. Okay? So in order for the inverse to be a function, we have to make it so that the original function passes the horizontal line test plus the vertical line test. All right, so let's look at example A. First, determine whether there is an inverse function. Right? For the inverse to be a function, remember, this thing has to pass both the vertical and the horizontal line test. All right, so you may need to graph one of these. Okay, so why don't we just take a quick sec and get a graph of this. All right, so here we are in Desmos, and I have taken the liberty of graphing x minus 1 over x plus 2. Okay, don't skip over this. Do this one, follow along, don't fast forward me right now. Okay, trust me, you're going to need this to be successful in this day 6 stuff. So, okay, one helpful hint, please, if you're putting a graph into a calculator, doesn't have to be Desmos, it could be your TI-84 or 83. If you're doing a fraction that has more than one term in it, put parentheses around it. Okay, put parentheses around it, because remember, your calculator does, PEM-DAS. So if you don't have parentheses around it, you may not have all of your denominator in the denominator according to your calculator. Okay, so this one looks good. All right, now here's your graph. Now let's answer this question here. Okay, it says, determine whether f has an inverse function. Well, remember, it has to pass a one-to-one test. Okay, this definitely is a function in itself. F of x is a function, but it does not, oh, excuse me, it does actually. Look at that. I can't find any horizontal lines on my grid that would possibly intersect the original function more than once. So this function is ready to be a one-to-one that will have an inverse that is a function. Okay, this is a one-to-one function right now. So I'm going to put the share back on my tablet, and let's do this. Okay, so f of x does have an inverse function. Why? Because f of x is 1 to 1. Okay, that just means that f inverse actually exists. Okay, there is an f inverse. So how do we find f inverse? Well, we already told you. 2 steps. Switch x and y, and then isolate your y. So first thing I'm going to do is I'm going to remember that f of x is just another way of saying y. All right? Second thing I'm going to do is I'm going to change the y to x. And I'm going to change my x's to y. Okay, so now we're going to do a little old-fashioned algebra. We have to solve for y. All right, I'm just going to do it. Watch, okay, watch, check it out. I like to cross multiply, so I'm going to put a 1 under here so I can visualize. If you don't like to cross multiply, you're just going to multiply both sides of the equation by y plus 2, and you're going to get the same thing as I get in this step. But I'm going to cross multiply 1 times y minus 1, and I'm going to get y minus 1 equals, and then I'm going to cross multiply, and I've got x times y plus 2. Okay. All right, so I'm going to put a little border for my workspace here. All right, next up, we have to isolate the y. The only way I'm going to be able to isolate y here is I need to first, that's right, distribute your x, okay? Can't have any parentheses in here. So we've got y minus 1 equals x times y, which is just xy, plus 2 times x, which is 2x. Okay. Next thing we need to do here, we're still trying to isolate y. We need to get all the y terms on one side of the equal sign, and then everything else on the other side. So let's isolate the y terms. I see 2 y terms here. I see y by itself, and I see xy. So let's add 1 to both sides, and let's subtract xy from both sides. Okay, so I've got y minus xy on the left equals, and then I've got 2x plus 1, because those cancel, 2x plus 1. Okay, we're making good progress. We only have y terms on the left, and we only have non-y terms on the right. So we are going to have to factor out the GCF, or actually all we're going to do is factor out y because we really want y, right? So even if there's more of a GCF than y, just factor out the y so that you can do this, y parentheses, okay? So factor y out of both of these terms. Y divided by y is 1. Xy divided by y is x equals 2x plus 1. There, that was the hard part. Now I've got y times something. Go back to algebra 1. Y times something, I'm going to divide by the something. So I'm just going to divide both sides by 1 minus x. These 1 minus x's cancel. And so I've got y equals this right here, right? Now we're not going to call it y because we started with f of x. We switched x and y. So this is our f inverse. This is our f inverse of x. Okay, we're calling it f inverse equals 2x plus 1 over 1 minus x. Okay, lovely. Okay, now the rest of the question, after it says find the inverse, okay, we just did. Now it says give the domain of f inverse, including any restrictions that you may have inherited from f. Okay, well, you could do this a couple of ways. Okay, first thing you can do is you can look at the range of your original. So I'm going to go back to Desmos here, so you can look at the range, which should make a little sense here when we do this. Check it out. Okay, so here we are back at the same equation we had, x minus 1 over x plus 2. This was your f of x, okay? This is your f of x. So they're saying, what was the range? Okay, the range of my f started down here at negative infinity, and it went up, 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 up until right here. And then it hops over, looks like it hops over 1, doesn't it? Okay, the visual will be a little bit easier if I graph the line y equals 1. Let's graph it in green and make it dashed. Okay, let's do that. So this is y equals 1. You can see that the range starts down here, negative infinity, and it's coming up. It gets really close to 1, and then it hops over 1. And then you can see that it goes to infinity. All right, so the range of your original function was negative infinity to 1, parentheses, union 1 to infinity. That should make a lot of sense if you go back here and you look at your new f inverse of x. Check it out. All right, so check it. Look what we have here for our f inverse, okay? If I want the domain of f inverse, we learned that there's only 2 things that can restrict a domain. First thing is square root that might be negative in the radicand. The second thing is a denominator that might be 0, which you can't have. Well, what is the denominator here? It's 1 minus x. 1 minus x cannot be 0. Okay, so if I add x to both sides, I've got x cannot be 1, which is exactly what we just saw the range was of f of x. So in interval notation, the domain of f inverse, okay, so this guy right here, the domain is x must be anything except our good friend 1. Okay, that's a domain. Right? So what is the range of the f inverse? Okay, did they ask us that? Let's see. Well, the domain of f inverse, include any restriction. Oh, they didn't ask us that. If they do ask us, all you need to do is look at the domain from the original f. Okay, so if they had asked you for the range, which they didn't, but you could literally go back here and then do the same thing. Because remember, your range, the range of the inverse function is the domain of the previous f of x, the previous function. So we could literally say, look, x plus 2 does not equal 0. Okay, so the range is going to be everything except for negative 2. You're going to have x does not equal negative 2. Okay, so you'd have negative infinity to negative 2, union negative 2 to infinity. I know they didn't ask it here, but it's easy to see once we look at finding the domain of the f inverse being the range of f, then we can look at saying, well, let's find the domain of f, and that'll be the range of x inverse. Okay, so let's, or f inverse. Let's do that here with root of x minus 1. Right, so we'll quickly graph this. Okay, and there it is. So the square root of x minus 1. Okay, the first question within question 2 is, does f inverse exist? So is this question passes the going to be a function. F inverse is a function here. right? So yes, F inverse of X exists, okay, because F of X passes the horizontal line test, okay? This is a one-to-one function. It passes the horizontal line test, HLT, okay? So that means we can go ahead and find our F inverse, okay? So how do we find F inverse? Step one, we're going to remember that this is the same as Y. F of X and Y is the same thing, okay? So we're going to change Y to X, and we're going to change the X to a Y, all right? So let's isolate the Y. Well, we got to get rid of the square root. That's one thing we got to absolutely get rid of. So that means we're going to have to square both sides. Okay. If I square both sides, X squared equals Y minus 1. And now we just add 1 to both sides. So we have Y is equal to X squared plus 1. But remember, this Y, we swapped X's and Y's, so this is our F inverse. F inverse of X equals X squared plus 1. Okay? Cool beans. So now they asked us, and this time we'll only find the domain. What is the domain of F inverse? Okay, so what is the domain of F inverse? Well, let's go back to Desmos just for a second and look for the range, because the range of the original function is the domain of the inverse. So check it out. Okay, Y coordinates. How low does the function go? All right, you can see that it goes as low as 0, and then it's going up to infinity. Okay, from 0 to infinity. So here it is. So it was 0 to infinity, and it included the 0. So we're going to go 0 to infinity. Okay, so because that was the range of F of X, that is your domain of F inverse of X. Okay, and that's it for question 2. Let's move on here to question 3. Let's put this into a graphing calculator and see what this thing looks like. All right, here it is. This is 7 over the square root of X plus 3. All right, so first off, does this graph appear to be one-to-one? All right, I would say yes, it passes the horizontal line test again. So we would say that F inverse exists because it passes the horizontal line test. Okay. Just one other quick thing that we want to look at before we go here. Let's just take an eyeball look at, as I zoom out, what it looks like the range is going to be for the original function, right? What does this range look like? It looks like it's getting really close to the x-axis. It's not touching. We're going out to 1200, we're going out to 2500. It's not going below it. I don't think it's ever going to touch it. Okay, so if we said we want to look at the x, I mean, the x-axis is just y equals 0 if you wanted to graph it. All right, we can make it dashed if we want, make it all pretty there. All right, and you could see that these two graphs don't look like they're ever going to intersect, but it does look like the range goes down pretty close to 0, real close to 0, and then it goes up to infinity. Okay, all right, so with that in mind, the range being 0 to infinity, let's go back and let's finish question 3. Okay, so we have said that F inverse does exist because your F of X is 1-to-1, which means that it does pass the horizontal line test as well as the vertical line test, obviously. And we also said that the range of f of x was 0, but not including 0, so we put a parenthesis there, to infinity. Okay, so because f inverse of x does exist, right, then we can say, how do we find f inverse of x? Well, we're going to find it by, once again, remembering that f of x is y, and now we're going to change y to x, and we're going to change x to y. So 7 over root, not x plus 3, but y plus 3. Okay, so again, we have a fraction on one side. I really like to cross multiply, but again, if you don't want to, just think of it as multiplying both sides of the equation by root y plus 3. So I'm going to cross multiply here, and I'm going to get x times root of y plus 3 equals, and I'm going to cross multiply here and get 7 times 1, which is 7. Okay. Take that out for a second, make it look a little bit nicer. All right, so next, again, we're trying to isolate the y. So that means I got to isolate the square root. Well, that x is extra, so I got to get rid of that first. So I'm going to divide both sides by x. Okay, so these cancel, leaving me with root of y plus 3 equals 7 over x. Cool. Again, I am chiseling away until I get just y. So now I got to get rid of this square root. How do we get rid of square root? We square both sides. Okay, that'll eliminate the square root, inverse operations. So we have just y plus 3, because the squared and the square root cancel each other out. 7 squared is 49. X squared is x squared. So now the last thing we need to do, we're going to subtract 3 from both sides. Okay, and there we have it. Y equals 49 over x squared minus 3. It's kind of neat. Let's just rewrite it one last time as f inverse of x instead of y equals 49 over x squared minus 3. Okay, so there's our f inverse. We've got that done, and then it asks us for the domain. The domain of f inverse. Okay, so we can just say, I know what the domain of f inverse is because the x's of f inverse used to be the y coordinates in the original f. Well, the original y's were 0 to infinity. Okay, absolutely positively has to be. Okay, well, check this out. 0 to infinity. If you don't know why there's a parenthesis there, check it. There's an x squared in the denominator. All right, that's why you cannot have 0 there. Okay, so the range of f of x, we're going to bring it right down here, and that's going to be our domain for f inverse. Okay, 0 to infinity. Do not, this is a warning here, do not forget to find this range of f of x. Okay, if all you do is you look at this, then you're going to forget what we said previously about any restrictions that were inherited from f. Okay, there was a restriction there. Okay? There were restrictions within it. We didn't restrict it, but there were restrictions. Okay, because if I type in this whole thing, if I type that whole thing in, all right, you're not going to get this for your domain. Okay, we must restrict it to 0 to infinity. Okay, I'm going to leave it right there. We could go on about y, about the visuals, about the y equals x line. Okay, I'm going to leave it right there. You've got your F inverse. This is your domain. Okay. Next up, use the graph of this function below to graph its inverse. Right? That should be simple enough. Let's make it a little bit bigger here so that we can see this one a little bit nicer. Okay. This is the easiest part of this assignment. Guarantee it. This is the easiest part. All you're going to do is just remember that x and y change. All you need to remember is that x and y change, right? So you have some points that go through the grid, all right? I see that 0, 2 in your, we'll call this one f of x, the gray one here, f of x, okay? We have 0, 2. What else do we have? We have this point right here. That's 1, 3. Oh, look right there. It's on the grid. -1, 1. Where else do we have on the grid? It looks like this one's on the grid. So -2, -6. Any others on the grid? Yeah, this one looks like it's on the grid right there. We're going to go +2, 10. Okay. So F inverse, again, this is the easiest part of this particular lesson. Watch. Okay, watch. All I'm going to do is take the x's from f of x, and I'm going to make them my y's. And I'm going to take the y's from f of x, and I'm going to make them my x's. Ooh. Hopefully you're saying, wait a minute, he has typo. Yes, even though I'm not typing, okay? This guy right here, we got to switch him, okay? So this is going to be 1, -1. Okay? This is going to be -6, -2. This is going to be 10, 2. Okay, let's plot these points. That's it. Just plot the points, connect the dots. We should have a good day right there. We got 2, 0. So 2, 0 is the mirror image of 0, 2. 3, 1. So 3, 1. It's a mirror image of 1, 3. 1, -1. -6, -2. Right about there. Okay. Pretty close. And then 10, 2. Okay, so let's see what this baby looks like. Just coming through. 2. Okay, for those of you that are visual, if you remember the line y equals x, okay, remember these are symmetric over the line y equals x. If you take the gray and you fold it, it should fold right onto the orange. Okay, that's it for example C. Okay, so let's look at example D. Okay, we have a word problem. Yay, all right, little application. All right, so the amount an electrician charges can be modeled by the function f of x equals 60 plus 55x, where x is the number of hours worked. Okay, so again, x is number of hours, and it says the function, okay, is modeling an amount the electrician charges. So the f of x, the function, models the money. Okay, wait, it's money. It's green, okay? All right, so find an equation for the inverse function. All right, well, they gave us a function. Now we're going to find an equation for the inverse function. So instead of f of x, remember, f of x is just a fancy way that we say y, right? I'm going to switch y to x, and I'm going to switch X to Y. Okay, good old algebra 1. Let's go back and let's solve it for Y. Okay, so we got to subtract 60. Subtract 60. So we get X minus 60 over here. Those cancel. We got 0 plus 55Y, so 55Y. And then the last thing we have to do to isolate my Y is we have to divide by 55. Divide this whole thing, not just the X, not just the 60. Divide the whole thing by 55. So I've got Y equals X minus 60 over 55. Well, we're not going to call it Y. This is our inverse function. So our inverse function is F inverse of X equals X minus 60 over 55. So remember, we took the Y's and switched them to X's, and we took the X's and switched them to Y's from the original function. So use that to answer this question. What does X represent in the inverse function? Okay, so remember, the X in the inverse used to be the Y, or the F of X, in the original. Well, what did the F of X in the original represent? That was the money charged by the electrician. That's it. I hope you're saying, wow, this is a lot easier stuff than the graphing was. Okay, yeah, this isn't bad at all. Okay, so why would you want to find the inverse function? Because the first function, you're solving for this F of X, this Y, you're solving for the money. Well, what if you know how much money you're paying and you want to know how many hours? You want to solve for the hours. Well, here, okay, in my inverse function, the X represents the money, and this, the Y, represents the hours. So F inverse of X, but it's not X anymore. It's not X anymore because our X, the amount of money is 225, equals X minus 60, but it's not X, it's 225 over 55. Okay. Now you can just, if you want to do it in your head, easy peasy. 225 minus 60 is 165, divided by 55 is 3. Okay, so for $225, the electrician worked 3 hours. Now, I don't want Mr. Berry taking any partial credit away from me. I am greedy and I want every point on my tests and my quizzes. So doggone it, I am going to write my labels down. Okay? All right. That's all we have for you here. I hope that you go back and make sure that you follow those steps. Make sure that if you have questions, you ask them, ask them before next class if you need to. But this should help you a lot in day 6 and on the review. So till next class, see ya.